In example 7c, the function we are going to examine is h of x is equal to negative x cubed over 3x squared minus 9. So we need to test this function algebraically to see if it is even, odd, or neither. Okay, this is going to be a bit challenging because the function here is a fraction. Okay, all right, so the first thing, as always, we need to rewrite this function in a more workable format. Okay, so we are going to change the h of x over to y. Okay, and then we need to break down the exponents on the right side. Okay, so in the numerator, negative x cubed is going to be, we're going to leave the negative out front, and then we're going to change the x cubed to be x times x times x. The bottom is going to be 3 times x squared. X squared is going to break down into x times x, and then we will have minus 9. Okay, so going forward, this is how we want to work with this particular function. Okay, we are going to start by testing this function to see if it is even. Okay, so let me scoot down here. All right, so if we are testing this function to see if it is even, okay, we're testing it for y-axis symmetry. And so that means that if we start with a point xy, since we're testing for y-axis symmetry, y is going to stay put, and we're going to change every instance of x to negative x. Okay, so let's do it. Okay, so we're going to have y equals, in the numerator, we're going to have this negative sign is already present. Okay, so I'm going to put it down and I'm going to highlight it in yellow. Okay, so make sure you realize that negative sign is already there. Now, x times x times x, you need to replace each instance of x with negative x. Okay, so we will get negative x times negative x times negative x. Okay, that is what the numerator should look like. Okay, then in the bottom, we're going to have 3 times x times x. The x times x is going to turn into negative x times negative x, and don't forget the minus 9. Okay, we need to simplify this, okay, to see if we get the original function back. Okay, so we've got y equals, in the numerator. Okay, let's handle the sign first. Negative times negative is positive, times negative is negative, times negative is positive. Okay, so the numerator is going to end up positive, and x times x times x is going to be x cubed. Okay, the denominator, okay, we've got 3, and then negative times negative will turn this positive. X times x is x squared. Okay, so you're going to have 3x squared minus 9. We are simplified here. Let's compare it to the original function. Okay, in the original function, you can see if you're comparing, the denominators are the same. Okay, they're both 3x squared minus 9. Okay, the numerators are different. We've simplified here and we ended up with positive x cubed, but in the original function, it was a negative x cubed. Okay, so this is not the original function. So we can conclude that this function does not have y-axis symmetry. It is not even. Okay, so now we have to go do a separate test to see if this function is odd. Okay, so let's go over here. Okay, I'm going to put a different color. Okay, so for odd, we are testing for origin symmetry. And so the rule for that is if you start with a point xy, you need to make both replacements. You need to change x to negative x and y to negative y. Okay, so let's do it. Okay, go to your function in the box. We're going to replace y with negative y. Okay, and then we're going to have that equals, let's look at the numerator. Remember that minus sign, we're going to put it in yellow again. It's just hanging out front. Okay, then you've got x times x times x. Each of those x's have to change over to negative x. Okay, in the denominator, we are going to have 3 times, we're going to replace each instance of x with negative x, so we're going to get this. Okay, don't forget the minus 9. All right, we need to simplify this. Okay, on the left, let's leave the y negative for a minute. Okay, On the right side, this is exactly what we had when we did the even test. So the right side, the numerator will simplify to be positive x cubed over 3x squared minus 9. Okay, now here comes the tricky part. You need to compare apples to apples. The original function is y equals. We have negative y equals. Okay, so we need to change this over to positive y. Okay, in order to do that, we're going to multiply both sides by -1. Okay, so let's do that. Okay, this is where I think in section 3.1 we did an example and we talked about how you correctly multiply a fraction by -1. Okay, this is where that example comes into play. You have to remember how to correctly multiply a fraction by -1. The left side is going to be easy. -1 times -y is going to be positive y. Okay, so then you've got to take this fraction x cubed over 3x squared minus 9 and multiply it by 1. Okay, so the question was, do you multiply the numerator by -1? Do you multiply the denominator by -1? Or do you multiply both by -1? Okay, when we talked about this back in section 3.1, we said, hey, make the -1 a fraction by putting it over 1. And then recall how you multiply fractions. You multiply across the top and across the bottom. Okay, so this is going to be, you multiply across the top, it's going to be -1 times x cubed. And then the bottom is going to be 1 times the denominator. Okay, if we simplify this, okay, this tells us that y equals -x cubed. And then in the bottom, if you're just multiplying 3x squared minus 9 by 1, it doesn't change it. And this is how it simplifies. If you compare this fraction to the original function, you get the same exact thing back. The numerator is -x cubed, and the denominator is 3x squared minus 9. Okay, so this is the original function. So we can conclude that the function has origin symmetry, so this function is odd. Okay, it's going to have origin symmetry. Okay, all right, this is something, again, we've done this algebraically, but we can check ourselves on the calculator. Okay, if we go to our calculator and we type this function into y equals, okay, be careful here as far as plugging it in. Especially if you have an older calculator, you need to make sure that the numerator is in parentheses and the denominator is in parentheses. That way the calculator does this correctly. Okay, so I'm going to be abundantly cautious here. I'm going to put the numerator in parentheses, so -x cubed. And then I'm going to do the division and I'm going to put the denominator in parentheses. So it is 3x squared minus 9. Okay, so numerator in parentheses, denominator in parentheses, just to be cautious. Okay, all right, so let me make sure I put that in right. Yes. Okay, so now if we graph it, okay, we used our standard window, and this guy does not have y-axis symmetry. Okay, it does not. Okay, if you folded the sheet of paper along the y-axis, this little piece, if you can see where my arrow is, it should be over here. You don't have that. If you tested this for origin symmetry, remember, pick a point specifically on the graph. Okay, so maybe like this point right here, if you can see where my cursor is. Okay, and then remember, if the graph has origin symmetry, then that means if you take both of these coordinates are positive. Okay, so if you change the sign of both coordinates, that means, the -x and the -y should be on the graph as well, and it would end up over here. Okay, you could definitely pick a point on this segment as well and try to estimate its coordinates and then change the sign of both coordinates. Okay, and that point should pop up on the segment over here. Okay, so if you kind of tested out various points, you would see, even though this is a complicated looking graph, you would see that this guy has origin symmetry.